All right, awesome. We may as well get underway. My name's Peter Hanssens. We're going to do an end of year wrap for the data engineering meetup this year. Is my volume coming through all right? Show of hand, thumbs up. Yep, all good. Wonderful. So we've got a bit of a mix of content today for you, just to mix things up. Usually we have 2 or 3 speakers taking you through a technical topic or two for the meetup, but this time around we're doing I'm going to be taking you through a quick roundup of the meetup for the year. Then we're going to do some wraps. Just a couple. We've got a few of the vendors, Fivetran, Snowflake, Databricks, Confluent, taking us through what happened on their particular products this year and what they've got in store for 2021. And then we've got an awesome panel. We've got folks from established startups to really new, exciting data engineering startups to just folks that have been in and around the traps for quite some time that have got a lot of wisdom to share with us. So I think that's going to be really awesome. Cool. So to get us started, I want to quickly take you through a bit of a roundup of what happened this year. So we had 15 meetups, 1 mentoring session and 6 workshops. And definitely I hope it's been your impression so far that you've gotten a lot out of the whole being part of the community. You've learned a lot being part of this, and obviously that we've been able to keep everyone together despite everything that's happened with COVID-19 and the lockdowns. And I think actually it's worked out well in some respects, because we've been able to reach folks that aren't typically, able to attend meetups, folks that are outside of particular capital city regions and things like that. We had 1 face-to-face meetup. We were planning a second, and that got cancelled. So that was really cool to have that. Then we had, because of the popularity of the meetup, we decided to do DataEng Bites. It was originally going to be DataEng Conf AU, but in the end we decided, because of COVID-19 and all the risks associated with it, it just made sense to have a virtual conference. And we had 15 speakers there, over 700 tickets sold, even though they were free, I guess, and ended up with 390 YouTube followers. So I wanted to take the opportunity again, after it being such a massive success, to thank all of our sponsors: Snowflake, MongoDB, Databricks, AWS, Microsoft Azure, Fivetran, Confluent, ThoughtWorks, Instacluster, Canva, Yale Conferences, and CrowdShuttle. And also a big thank you to all of the awesome organisers that helped out. It was really good fun working with all of them. So just wanted to take you through a couple of the trends that are happening in the data engineering scene. I guess what we're seeing, well, what I'm particularly seeing at the moment, is that we're having less code, more serverless, and data engineers are leveraging patterns more often. So what I mean by less code is that I think a lot of folks are coming into the similar challenges each and every time, where we're basically the more custom code that they've got, the more blast radius for different issues arising. And so whilst data engineers are constantly coding, there's definitely a desire to do less of it. And you can see that with, custom connectors, or like pre-baked connectors and things like that. Tools like Fivetran and Stitch Starter and Omnata is a new company out there that are helping with all of this. More serverless. Data engineers don't want to be running their own, Kafka clusters, for instance, or a lot of the infrastructure side of things. And so there's a big trend towards not having to worry about, the scalability sort of concerns and things like that. I think with patterns, folks are really looking to leverage and patternize code so that they're not having to reinvent the wheel each time that they're building a new data engineering task. So who are data engineers first and foremost? I think there's been a lot of, conjecture around where data engineers came from and what was the cause of data engineering becoming so popular, because it is wildly popular. You look at LinkedIn at the moment, it just seems like there's hundreds and hundreds of jobs for data engineers out there. And I think the key of it is that we're not a subset of data science, and potentially the reason why data engineering is so successful and so popular right now is because data science didn't really live up to the promise. I think it was probably 4 or 5 years ago, if you looked at a lot of blog posts and things like that, it's just like, oh yeah, just hire a couple of data scientists, and all your data is going to be going to be solved within your organization. That's not really been the case. They tried to do too many things too often, and it didn't really work out too well. So data engineers have their roots in business intelligence. They've got a massive influence from software engineering. In fact, pretty much data engineers are glorified software engineers with a bit of data, background as well. So, and I think now people are understanding that structured data teams are the way to win the game. So data engineers really came to the fore, especially in startup land where data needed to be onboarded really quickly. Also, the advent of microservices architectures and SaaS products like Stripe and Braintree, they kind of drove this need for folks to really focus on just bringing all of this data and centralizing it into a warehouse or a data lake so that the rest of the business can do some analysis and things like that on it. And I think there was this realization, if you just had a single data scientist, for instance, in the business, that you weren't really going to do a great job doing data in a business. So we've got a couple of new roles these days, and a lot of this has sort of come from the Fishtown Analytics DBT ecosystem. But I think still we've got the traditional data analyst that's really strong with SQL and probably got a bit of Python under their belts. The analytics engineer is a new type of role that's sprung up. They're kind of like a data engineer, but not really requiring all of that software engineering rigor. Tools like Fivetran and Stitch Data and others are allowing analytics engineers to be able to build data pipelines without actually having to know about all of the infrastructure and software development lifecycle considerations that you might need. The warehouse engineer, they're a bit more concerned with making sense of the data, if you will, like organizing the data, say in a Kimball or a Data Vault methodology. And of course, data engineers, they're really tasked with just surfacing data from application databases and other places. Another interesting development this year has been that DBT is now a platform. So we're seeing tools like, as I mentioned, Fivetran, Stitch, Amazon AppFlow is another one that are surfacing data into a warehouse. DBT then goes ahead and does a bunch of transformations over the top of that data. And then you've got tools like Hanssens and Omnata, which is a local startup. I'm sure James will talk to us about it a bit later, where you can sort of take that data that's being curated within a warehouse and ship it off to somewhere else like Salesforce, where all of that enriched data can greatly assist folks that are doing, sales type roles or customer service type roles. Think of tools like Zendesk and the like. So I've mentioned, that microservices architecture, and a lot of people talk about, microservices architectures, occasionally getting into this big blob of spaghetti. No one really knows how to make a lot of sense out of it. And, we spoke at last year's end of year wrap about the data mesh concept, and we also had Mark Dagani talk about it at DataEng Bytes. And I think, at its core, the simplest way to understand it is probably pushing the semantic layer back down to the microservices. So really having microservices in charge of managing their schema and the like, and exposing that. And folks have talked about this concept of DATSIS, so making data discoverable, addressable, trustworthy, self-describing, interoperable, and secure. And I think that's kind of pushing data lineage and metadata is definitely something that's well solved in the enterprise space. Well, there are enterprise tools out there that cost a reasonable amount of money to acquire, but that's reasonably mature. But I think startups are definitely starting to embrace this. There's an open source community. We had a talk a couple of months ago on a Munson, and I think it'll be cool to see some SaaS apps in this space where you're just able to sort of plug and play a data discovery metadata tool onto your various airflows and data warehouses and things like that. So I wanted to quickly touch on another thing that's of interest, the recent AWS outage in US East 1. I mean, we do need to consider the fact that this was only a brief outage, probably 4 to 6 hours. When you consider in terms of availability, it wasn't the biggest outage in the world, but obviously it exposed a bit the service dependencies that AWS itself has on its own event bus, which is Kinesis and things like that. And I think it's another reason why the popularity of Confluent and using Kinesis itself are growing so much, in the sense that if the hundreds and thousands of engineers that AWS have find it hard to basically have near perfect uptime, then what hope do we have? And we could see this, and I guess another hot take to take out of this is the fact that all the inter-service dependencies that AWS had on Kinesis, the fact that CloudWatch was dependent on Kinesis, those metrics that drive auto-scaling, Lambda, ECS, EKS, all were having flow-on effects. And what sort of flow-on effects do you have in your company with your event buses and things like that? And it makes you think, doesn't it? So anyway, that's just my 5 cents worth in terms of what trends I'm seeing in data engineering this year. Keen to hear in the chat what you thought about that, and what you think about some of the wraps that we're going to have from our industry vendors, and then some questions for our panelists. So without further ado, I will hand it over to James from Confluent.
Great, thanks, Peter. And when you said James is going to talk to you about census, I'm like, I don't know if I can. Different James, I understand now. So yeah, look, thanks very much. I won't take much time. I know we're keen to get to the panel. So really, just to understand what Confluent do for the start, some people may not understand. We're essentially an event streaming platform based on Kafka, and we really have two variants of our product. The first, which we started out with, was Confluent Platform, which is really self-managed, a self-managed version of the event streaming platform. And then we've more recently introduced Confluent Cloud. So looking back over the year, we've had we've had 2 minor and 1 major release of the Confluent platform, and they correspond with releases of the Apache Kafka open source project. So in those releases, so you can see as of Jan 2020, 5.4, we've introduced things into the Confluent platform around security. So obviously with enterprise, security is top of mind, and Apache Kafka, while it can be secured, there are additional things that enterprises are looking for. So role-based access control, audit logs, those kinds of things are really required, and so they've been added. Quite interesting in the context of this discussion is multi-region clusters, given outages. And so this is the ability to stretch a Kafka cluster across multiple geographical regions for that resilience. We also introduced sort of like schema validation. So part of the Confluent platform is around kind of a schema registry, and that's an important part of the platform. And we've enhanced the sort of like the ability of that schema registry to actually reject data that doesn't conform to particular schemas. We also sorry. No. So with also obviously management and monitoring here. So we have Confluent Control Center, but we also expose some of those metrics so that you can actually monitor in your own kind of like Grafana or Prometheus, or wherever you're monitoring. And we'll talk about tiered storage and in a first slide. With 5.5, I suppose started building again on kind of like that schema registry by introducing support for protobuf and JSON schemas, and also kind of like extensibility, so you can actually build your own, define your own schemas that will be handled by schema registry, and some various other sort of like things around kind of exactly once semantics. And so that was, it's been a busy year for us at the platform level. A lot of these features are also in cloud. And probably looking back on the year, we've really seen that people are looking for, as Peter was saying, that managed service where you don't have to be aware of Kafka Pro, because Kafka can be hard to manage. And so cloud is becoming kind of increasingly popular. So next slide, Peter. Yeah. So as I was mentioning, Kafka as a service, Confluent Cloud, that's where most of our new customers are looking. Really that's more than just Kafka. It's basically the only managed Kafka, fully managed Kafka service. But it adds sort of like these features that are really important when you're designing kind of enterprise applications. So as I mentioned, schema registry to ensure sort of like data governance and also data compatibility between the downstream applications. KSQL DB for that real-time stream processing, and then sort of like increasing our number of managed connectors in the cloud, so that you can actually connect to all of the data sources and data sinks that you commonly see without having to run any kind of like service on your own. I should also mention, like, I mean, I'm sure you're all very well aware of this, but Kafka, we play in that sort of fast data space. So it's kind of like the real-time data, real-time processing. So KSQL DB is very much concerned with that real-time processing, where you're looking at sub-second latencies for a message to flow through a system. And so that's driving, we see it a lot in banks, driving banking applications, real-time banking applications, those kinds of things. Just thought I should clarify that. Okay, next slide. Thanks, Peter. So looking forward, what are the things that we see as being really important? There's lots of things coming out next year. There's a lot of roadmap items I can't talk about. But the things that were actually announced as part of Confluent Platform 6, 2 that I really wanted to focus on. One was around tiered storage, and the other is cluster linking, because both of those are kind of like going to be an important shift for the way people are using Kafka. So next slide. Yeah, so tiered storage, one of the properties of Kafka is that it uses local disk. And so there's this idea that kind of like as you get more data, you become disk bound. So you're actually in order to expand the cluster, you need to add brokers just to get more disk space. But tiered storage really changes that. And what that does is it allows you to store a topic across two storage layers, one across the kind of like the mounted volumes, but then push the older data, the warm data set, into object storage. And so that effectively removes that idea of a broker becoming disk bound, because data can be pushed down to that kind of like object store, say S3. And that has virtually no effect on performance because of the way Kafka prefetches. So that was released as part of Confluent Platform 6, and it's actually in cloud, it's kind of just transparently there. It's known as infinite storage, so the ability to retain data infinitely rather than in the traditional message queue for a short term. And next slide, and I think this is the final one, so I know we need to move on. Yeah, cluster linking. So this gives you a good idea of cluster linking, that broken image. Is everyone seeing that or not seeing that? Yeah. Okay, so I will describe the image that was there. So cluster linking is this idea that, Kafka sits well in, because it's a distributed system, it sits well in geography, but latency is kind of like a, it's getting worse. Latency is actually a problem across geographies because of the way the distributed system works. And so there's a physical limit to how far you can actually stretch a cluster. Cluster linking is a really significant thing because it allows you to actually, it allows you to actually have multiple clusters across, across the world basically, and use the Kafka protocol to actually duplicate or replicate data between those clusters. And so I won't go into the details of that, but it's really important because it allows you to actually use these linked clusters, and those different geographies have access to the same data in the same kind of like, real time minus the cost of latency across the globe. So we are expecting to see this be a really big shift in the way enterprises use Kafka around global geographies. So that was it. Thank you very much for your time.
Thanks so much, James. Up next, we have Kelly.
Awesome. All right, 5 minutes to wrap up the year. No pressure. So yeah, just I guess starting really high level. One of the biggest things probably everyone has heard by now is the new kind of data cloud positioning or messaging. And with that data cloud came 6 key workloads, one of them being data engineering. And although it's a lot of marketing and all of that, what I think was really helpful about that messaging is that it really allowed Snowflake as well as our customers kind of understand those key areas where value is being driven, and also it was informed by what customers were actually doing. And so some of these areas are more mature than others. We started as that core data warehouse, so that's still the case now. That's still our sort of bread and butter. But data engineering is a very close second, I would say, followed by some of the other more advanced workloads. So other than that data cloud, I just was off the top of my head trying to think of some of the other key highlights. We launched a Data Heroes program. So I know James is one of our local data heroes, as well as a startup challenge, which is also super exciting, where if you build an app on Snowflake, we're giving away, I think it's $250,000 to that startup to launch. So really exciting space there. And then when it comes to actually pipelines and extensibility, there's been a lot of announcements over the last week in that space. I'll go into those in a second. We also had a brand new UI launch, as well as Snowsight, which is a very lightweight visualization, as well as data profiling capability. And finally, a lot of progress and development in the exchange, data exchange and data sharing space, with over 100 providers now on the Snowflake marketplace and many more customers utilizing Snowflake for those private exchanges as well. Next slide. So where are we now when it comes to data engineering? I'm not going to obviously go through this in too much detail here, but if you think about the workflow of a data engineer when it comes to actually getting your data in to the platform, doing your transformations on top of that, and then finally delivering it out to your end users, we've launched and progressed in many of these areas whether it's core platform features or specific things relating to data engineering. So I think one of the big ones I was going to highlight here is streams and tasks. So streams essentially will give you a built-in ability to have CDC and continuous, essentially continuous transformations together with tasks. And a lot of our customers have utilized these not just on top of tables in Snowflake, but also external tables. And so there's ways to utilize those capabilities across the platform. The other two at the bottom with semi-structured data support, as well as just resizing and scaling the warehouse very flexibly. Those have been on the platform from day one, but they have proven their value at many customers. I know Canva, for example, used that schema on read with semi-structured data to really fast track their migration to Snowflake. And it made the world of difference when it came to them developing a framework that could then be delivered across different data sources, no matter where those originated. Next slide. So where are we headed? Or where are we going? So there are sort of 4 key pillars that were announced as part of our big event last week. So whether it was the core capability of the platform, lots of work in the data governance space, data cloud content, which we'll touch on. But the big one was really that extensible data pipelines. And it's still early days, but our vision is to essentially allow data engineers to build these transformations on Snowflake in their preferred language and be able to optimize it from end to end in an automated way. And so some of those key capabilities that were announced included Snowpark, which is a brand new developer experience, starting with Scala and Java and eventually Python, but essentially allowing end users to utilize those languages of choice directly on Snowflake. Another one, which kind of ties back to what Peter was mentioning earlier, is tasks have been in platform for a while now, but we're going to be introducing serverless tasks, which takes away all of that, optimization, having to provision your own resource and so on. Next slide. And then the 2 that I'll just highlight here, the first is around unstructured data support. So this is currently in private preview, but we essentially can now access unstructured files in blob storage directly from Snowflake. We're able to query those files using SQL and generate pre-signed URLs and make it a lot more of a seamless experience for those end users at the end of the day to leverage those traditionally quite complex structures. Obviously, because that is native, you have the same governance controls that you would over any other data in Snowflake as well. And then lastly, the last slide here is around data services, which is in public preview. So this was a very natural progression from the data exchange and data marketplace, where the basis of those concepts was sharing data. With data services, it's more about sharing functions and logic on top of data. So, rather than exposing the actual data itself, what you're doing here is you're developing custom functions to then share externally or with your within your organization without actually exposing any of the underlying data itself. And that's all I had. I'm gonna do it in just under 6.
Nice. Thanks, Kelly. You're sticking around for the panel, right? Chat to you then.
I sure am.
Awesome. Cool. Databricks, we have Shelby.
Hi, everyone. I'm Shelby Ferson, if I haven't met you before. I'm definitely a lurker on the channel. I'm the manager of sales for the commercial team here across Australia and New Zealand, and I've actually been at Databricks for 4.5 years. So it's been quite an interesting ride, to say the least. I'm basically going to focus on our vision for next year. I think the next slide, if you want to just click it, Peter. I can talk briefly for those who aren't familiar with Databricks, but there was quite a few key events that really affected, I think, us as a company, but also, being founded by the same 6 founders of open source Apache Spark. Like James was saying, there's a lot of things that are driven by the open source project itself. So Databricks actually acquired Redash, and I don't know if everyone here is familiar with Redash, but what it was is an open source SQL interface to interact with data. So I'll talk a little bit more about how we're actually integrating that into the Databricks platform itself. Spark released 3.0, which is a huge achievement. And with that came a ton of performance improvements, as well as better support among different kind of languages, I would say mostly. And MLflow also reached 1.0, which is great to see. And we also released our Delta engine, which, for those who aren't familiar with Delta Lake, is also an open source project that was created by Databricks. What it does is basically provides, I like to say, data warehouse like capabilities on top of a data lake. So doing things like ACID transactions, schema validation, all of these things that a lot of our customers were struggling with data lakes. And we're seeing quite a bit of adoption, I think, even in this region from the open source project itself. And so how we're wrapping that up as a Databricks platform here is we're looking to connect to your data, where you have it stored within a blob storage S3, or even if you're, looking to have that on GCP, giving you that file format of Delta that provides optimization around, inherent file skipping when you're querying, things like that. And with that, we're basically able, with Spark at our core, provide a single platform for every single different type of use case. And that's what's great about, I think, Spark fundamentally, is I like to call it a multi-purpose, multi-language data processing engine. So it supports things like, streaming, so structured streaming, all the way from, doing SQL queries with Spark SQL. And as always, I think, Python and Scala. Scala was our originator language, I would say, but we've obviously seen Python has definitely kind of been the one that's overtook it. So Peter, I guess if you're going to go to the next slide, please. So just to dive in a little bit more about what we're really focusing on this year, and I think everyone here is seeing the rise of the terminology, the lakehouse. And so Databricks really saw this opportunity to really kind of build the foundation on top of Delta Lake to enable companies to build lake houses. And so what is that? Lakehouse is a data platform to enable BI, data science, and machine learning on data that's sitting in a data lake. And so this next year, we're going to be focusing mostly within the Databricks platform on the SQL user experience, set up an admin across multiple clouds using Databricks, as well as performance and query concurrency. Do you want to click next, please? I'm going to try and keep this pretty quick. So for where we were seeing Databricks from an extensible platform, I think we handle data engineering and data science and machine learning very well with our very nice notebooks and the integration to MLflow and creating this really nice CI/CD pipeline for machine learning engineers as well as data scientists, and then Spark being a really great, inherent data processing engine for big data at the data engineering level. So I feel like we had a really good grasp on all of these different personas, but the one we were really missing was this SQL persona. So how could we give the SQL persona a lot of love and attention, and basically give them the ability to access the data that's sitting in a data lake, that the data engineers were usually kind of the bottleneck of for servicing all of these, analysts and data scientists. And so what we've done here is we've actually, within the UI, we've integrated Redash. And so we're giving the SQL users basically a home within Databricks. And it's a great BI experience, as well as we've re-architected. We found that Spark inherently with the execution log was causing some performance issues when it came to concurrent queries and how we handled concurrency. So we recognized that about, I would say, 2 years ago. So what we went ahead and did is actually built from the ground up a different engine to support the concurrency as well as SQL users, to make sure that when we do release, this is very early days, but when we're trying to service these kind of users, we wanted to make sure that they were having a good experience in accessing data from a data lake. And so where we put it now is that it's very easy to use, very comfortable for a classic SQL user from a UI experience level, and also the ability to do things like sharing of the queries and things like that that you would get. I think next slide. I think I've got one more. Yeah, so this is the Delta engine. So in Photon here. So I just wanted to touch on this quickly. So what we went ahead and did is basically tested how we were doing around the performance. And obviously, as I mentioned earlier, we recognized that with Spark itself, we were actually, it was struggling to keep up with that performance requirements across larger enterprises. And so what we've done is basically re-architected the engine that sits behind that. Called Photon, and that's within Databricks from a platform perspective. Right now it's in private preview. That's kind of where we're headed next year, and it should be released sometime next year. But that is filling that gap, I think, from a SQL end user perspective. So hopefully we can lift some of the I would say strain on the data engineering crew who supports those end users and really service them. And also we're seeing it be an engine that companies are also connecting their BI tools, so that the BI tools are directly connected to the data lake. And so there's that single source of truth, and that's kind of, I think, what the lakehouse paradigm we're seeing really kind of gain a ton of traction. And it's funny, we actually internally we're looking at where did that term come from, and Ali, our CEO, actually had mentioned it, had a specific talk on it during our Spark Summit EU in 2019. So it's nice to see that things finally are catching up and gaining traction, and fundamentally I think we see these trends just take some time. So that's me. Hopefully, I think I did 5 minutes. If you do have any specific questions, feel free to ping me on the channel. I'm an open book, and if you have more technical questions, always happy to connect you to one of our solution engineers. Thanks, Peter, for having me.
Thanks so much, Shelby. Really appreciate it. Cool. Now we've got Dom Colyer from Fivetran to take us through all things Fivetran.
Hey, everyone. Good afternoon. I would like to just a quick shout out to start mine off to Peter and Simon and the whole team putting this together across the whole year. It takes a lot of effort to get content and speakers, so kudos to you both for all your hard efforts. But let's jump in. We can go to the next slide, Peter. So high-level overview for Fivetran this year. We've got the ANZ team. Yay, that's us. We're here. We're people. We're so happy to be in region. There's 9 of us now, hopefully growing more, a lot more next year. But yeah, so glad to be here and be able to work with everyone, some of our partners and customers on this panel and dialed in as well. Obviously, with our launch here, the data center in Sydney was a big milestone for us, and new ones of those coming, which I'll get to in a second. Obviously, Fivetran is mainly about the connectors, but we had a few kind of big platform features we launched this year. We changed our pricing model to be consumption-based pricing, which kind of helped out the smaller people kind of starting up and made it a bit more reasonable for our larger clients as well, to just kind of level that playing field for everyone across the board. Online purchasing we launched only a few months ago, and that has been a great success for us. So people, where they want to start small, credit cards, using the marketplaces, just help people get up and running quicker. Nice milestone for us as a team. As I said, we only started in May. We've hit 100 customers recently. Again, a lot of you are on this call, some even on the panel. So super thankful for everyone for working with us. We've had a great time working with you all, and hopefully we can have that number a lot longer next year. Again, on the kind of platforms, security has been a big focus this year. We've hired our CISO. We've got our security docs kind of nice and streamlined to alleviate that pain, which is can always be a trouble in kind of SaaS-based solutions. DBT, that's been mentioned a lot. We've invested heavily in DBT, integrating with it and building a lot of open source DBT packages to help our customers kind of streamline their analytics piece as well as their data pipelines. History mode was a big one for us. That is changing the way we work into slowly changing dimension type 2 kind of architecture, which always is a lot of code. I remember writing a lot of code in my career to kind of achieve that. So helping out that space was a big one for us. Databricks, who are on the call, we got Databricks Delta Lake as one of our destinations as well, which was fantastic. New feature just a couple of weeks ago that dropped is our connector trial. So now everyone can have a 14-day free trial of any connector they wish. Again, trying to help you guys just get up and running quick and explore that kind of data without any restrictions. And hundreds and probably thousands of connect upgrades and schema changes. You can see the link to our change logs there. Our engineering team constantly just pushing those out. So a shout out to them for all the good work. New connectors, SAP S4 has been a real big one. We've had a ton of requests to that. So that's in private preview. We're super excited about that one. Box, Sage Intact, we've got a lot of Microsoft Dynamics 365 stuff up. Google Analytics and YouTube Analytics, a lot of stuff in the Azure space. Facebook ads, Google ads, you can see there a fair big push into the Oracle space. And also a lot of multi-threading and kind of performance improvements around them as well, which engineering's been really good on. Next slide, Pete. So our year actually ends in January, so we've still got a little bit left. So what's to come? We've got a Redshift partner integration, which is great. You can go straight from Redshift to Fivetran. Heaps of work, as I said, on DBT, more packages, more enhancements. That history mode that's on Salesforce, we're going to roll that out to all our databases, hopefully by the end of the year. And probably the biggest one we've been asked about heaps is S3 as a destination. So that should be in private preview by January. So exciting one there. Next slide again, what's coming next for 2021? Coming up on time. So universal column masking. So this is, you can select which columns and tables you want across all of our connectors, which is great for kind of compliance and PII workflows. DBT transformations will have triggers. So at the moment we only do scheduling, but we'll get some trigger-based stuff when pipelines are finished to trigger specific jobs. Not too many details on this next one, but there is a multi-cloud strategy coming. It's on the horizon. So that'll be a big part of the first half of next year. DBT packages, as I said, we're trying to get about one every 2 weeks to a month out. The key one I'll point out there is our ad connector. So that's going to be a multi-schema DBT package across a MarTech kind of use case. So really good to get kind of your clicks per view and really get those insights built out quickly for you. A whole stack of new connectors. We won't go through them all. The magic folder is probably a real cool one to point out. That'll just sync any file in a few of our different net connectors into different tables in your destination. Big push into Oracle, as I said, big push into SAP. And really a strategy next year is to kind of build on those enterprise strategies around those connectors and mainframes and stuff as well. So that's Fivetran. Again, we're super excited to be in region. We've had a fantastic year working with a lot of you of our partners and customers, and hoping to expand next year with you all.
Thanks so much, Dom, and thanks to all of the vendors. We try to definitely not make these like sales pitches. They're really just trying to keep you informed as data engineers on what's happening, because all of our vendors are really good fun for sort of making our job a little bit easier with all of the innovation that they're doing on our behalf, and also they help to pay for our great, data engineering conferences and things like that. So thanks once again for all of your support from the folks here today. Really appreciate it. Cool. So wanted to dive into our panelists. Didn't forget which order we were introducing people in. Up first is Nitish Mathew from Afterpay.
Thanks, Peter. Hi, my name is Nitish. So I work for Afterpay. I had the great honor to actually start the team there and build a platform a couple of years ago. And we actually work very closely with some of the vendors over here. And I'm super excited to be part of this group. And hats off to Peter and the entire team here in the data engineering group for their tremendous contribution to improving the state of data in Australia. I think Australia has become almost like the Silicon Valley of data in the world, thanks to them. And next slide, please. And look, I don't think I'm going to spend a lot of time on this this slide. Hopefully everybody knows Afterpay, and hopefully some of you in the panel and also in watching us have used Afterpay. If you have, thank you very much. I encourage all of you to explore Afterpay. We've become a very, very popular product, not just in Australia, but also a very prominent export, Australian export to the UK, US, now Canada, and hopefully to the other regions in the world. Thank you.
Thanks, Nitish. Suneeta.
Hi, thanks Peter for having me here. Really nice to be talking to everyone and engaging with the wider data engineering community. I'm Suneeta Mill. I work as a principal machine learning engineer at Nearmap. And I there lead a team called DataEng, who are essentially responsible for all the kind of data that's related to models. So the data that's needed to do model training, then data coming out of model training, so model training results, evaluation results, and also the data from model inferences, essentially model monitoring, and then making sure how we can use these various different data sources to continually improve the model performance. And I have a PhD from University of Sydney, and I have BTech Com Science background. Been in IT for about 13 years, doing lots of things on various different domains. I think I've settled pretty much on AI, machine learning at this point, but data is a very crucial part of it. I do speak on technical conferences, etc., and do author for some organizations, particularly O'Reilly. And I've also done a red book in past with a bunch of other folks.
Awesome.
Next slide, please, Peter. And Nearmap, essentially, if you haven't heard about us, we are one of the very own Sydney Australian organization, essentially stemmed from Perth, but we are heavily headquartered in Sydney. We specialize in providing high definition aerial imagery and location content. We provide in many different formats, like 2D taken from top down, or from many different angles like oblique, side view, or even 3D in point cloud, mesh clouds. We have been looking at how we can use AI and machine learning to generate what we call derived content. So we essentially take the raw data like a visual content and we run AI on top of it to generate more data. In many ways, it's again a product for us, which is quite common for SaaS, like a data as SaaS kind of setup. And we are capturing in Australia, New Zealand, US, and Canada at this point, and obviously looking to grow many organizations, many continents, sorry. And also one thing I would like to mention is a lot of the people think that we do drone imagery or satellite imagery, but at this point we are purely doing aerial imagery. We capture from a very high angle to get that high resolution, but we don't do at a drone level. It's definitely a possibility in future, but at this point we are purely aerial. And yep, that's it. I'm looking forward to see how we can help in the data community and have more interesting discussions.
Thanks, Suneeta. James, Weakley, there were two James on the chat. There was James from Confluent and James from a really cool, new, exciting startup called Omnata. Take it away.
Thanks, Peter. Thanks for inviting me. So, yeah, my background personally is as a software engineer / consultant. I think you said before, data engineers are like glorified software engineers. I think that's probably true for me. I've probably kind of honed in on the kind of data warehousing, data engineering space in about the last 5 years when it became popular to do so. And I've worked at a couple of companies using pretty much all of the products that have been covered today. In this sort of new age of cloud data platforms and tools. So very much been active as a buyer of those products over the years. As Kelly said, I was appointed the title of data superhero in the Snowflake community mainly for my open source contributions around that platform that just essentially were mostly related to the deployment and management of the platform. I do some technical blogging on Medium as well, which I like to do. I've also been known to speak publicly from time to time, although writing is probably my preferred medium. Next slide. Omnata is my new company, which is founded this year, and we're an Australian local startup, and really I've co-founded Omnata to solve the last mile problem primarily. So born out of a lot of field experience of working with data science teams where everyone always underestimated that last mile problem, or last kilometer problem, I guess, for the people on this call. And really just making data platforms a reality for the enterprise. So taking that investment that's being made more and more in the cloud data warehouse and its associated pipelines, the fact that there's curated, consolidated data on these platforms and that they can handle the concurrency and scale that they need to, that's a great thing to plug your enterprise apps into. You don't have to build custom or bespoke kind of large middleware solutions. In many cases, you can just live query those platforms and it works really well. The other thing is, in a lot of cases, you don't need to ship the data off to the next destination as well. In fact, many CRMs in particular aren't really built to handle large data sets. So that's where the live query aspect is really our big differentiator. Our initial combination is Snowflake and Salesforce, really just because, well, partly the dominant market share of Salesforce and also the suitability of Snowflake, and of course its trajectory in recent years is a big attractor. Going forward though, eventually supporting other combinations, but also definitely leveraging newer features, things like tasks and streams and external functions that make continuing that pipeline out into the application space much easier and convenient for users. So you can check out Omnata. Our LinkedIn page is a good one to follow, and also we are a Salesforce partner. We have our app is on the Salesforce App Exchange. You can find us there as well.
Thank you, James. And over to Bayan.
Hi, everyone. My name's Bayan, and I'm a data generalist. I'm a bit of everything. Most recently, I found my own startup with my brother, Aham, and that's Super Cool Data. We started a while back, but formally around June. And we've been tinkering with different ideas over the last year in the data engineering space. And I'll talk about Super Cool Data on the next slide. But most of my experience has actually been at domain.com.au, where I started off as a product analyst and was one of the first few employees in the data space there. And I saw the kind of growth of that. And we had Redshift and then moved to Snowflake. And that was where I draw a lot of experience. It's also where I spent a lot of time teaching people SQL, and that's how Super Cool Data kind of came about. And I started my data career at Servian, and before that, I didn't realize the significance of SQL. I started off with Python, but yeah, that's and my background is actually in civil engineering, and I studied finance. So that's a bit about me. And next slide. Yeah, so Super Cool Data. So this came about from my experience at Domain, where the BI team and my team, the analytics team, were getting smashed with requests. We had Tableau, and it kind of took into account, satisfy a lot of the questions that people had. But often the business person would be sitting next to me while I'll be drafting a query. And so that's kind of, I ran SQL courses at Domain. I taught probably over 100 people SQL, not all of them successfully, but I taught many people SQL, and a lot of the experience I had from that went into the product in terms of how we designed it and how I taught it. And one of the main learnings was that the reason why they were doing my course wasn't just to learn about SQL, which obviously there's a lot of resources online to learn SQL, but it's to learn about the domain's data and the schema that we had and how to calculate different things. So that's kind of where the motivation came from. And you can think of it as kind of like Duolingo for SQL. If you've tried Duolingo, it's a language learning app, but it's kind of like that. Yeah.
Awesome. Thanks, Bayan. And last but not least, we've got Kelly, who gave us the Snowflake wrap as well.
Feel like, yeah, I shouldn't be here. I'll take off my Snowflake hat and just be me. Yes, well, nice to meet everyone. My name is Kelly Hotta. I work at Snowflake at the moment. I have 8 years of pre-sales experience. So prior to Snowflake, I was at Tableau. And I really just love helping our customers use data in new ways and think of, I guess, new ways to approach old problems. Prior to all of that, I was in completely different industries. So I co-founded 2 startups in Singapore, one being a retail space, and the second being an F&B sort of distribution company. So pretty varied, I suppose, in my experience across those industries, always with a focus on data, though, which was what originally led me to Tableau. The last data point I put in here was just the fact that I realized my average length in a city was 3 years. So I've passed that in Sydney, so that's cool. But I suppose with that kind of moving around all the time and a lot of change growing up, I sort of like to seek that out today. And again, I really love hearing from customers how they're utilizing these new tools that are available. And one of the best parts of my job is meeting people like Bayan and James, who have started companies in the last year in these new exciting spaces. So yes, great to be here. Thanks for having me.
Awesome. Thanks, Kelly. Well, now it's time for the panel discussion. So let's dive into that. See how this is going to all work. We've got a couple of do feel free to shoot through your questions if you do have questions for our awesome panel. One second, I'm just bringing up the crew, and we have everyone. Awesome. Okay, we're ready to roll. Cool. So now. So we've all met all of our panelists. We've got James from Omnata, Bayan from Super Cool Data, Suneeta from Nearmap, Nitish from Afterpay, and Kelly from Snowflake. We've got a few questions, but I'd like to kick things off with what you're most excited to see about in coming up in 2021. You know, what's really sort of, I guess, keeping you really enthusiastic about data engineering or data more generally?
So I guess from my perspective, I have I guess I'm, as an analyst, I'm a consumer of the output of the work that data engineers do. And recently I had to set up my data warehouse on Fivetran, using Fivetran, and I set up BigQuery. And it was like really, really easy. As someone who might not be an expert in certain data engineering kind of practices. But one thing that isn't easy at the moment is setting up the real-time streams. And I kind of see that there's a lot of space for, I guess, maturity in that area. So for example, I was thinking if there was like a real Fivetran for real-time data, that would be something that I think is lacking, and it will enable and unlock a lot of things.
Yeah, I think from what I saw from the Fivetran conference, the Modern Data Architecture Conference, they themselves are looking to address that, and there's a lot of tools in this space, and I guess it's space that, you know, typically Kafka and Confluent and things like that play quite heavily in, but yeah, that is super exciting. Others?
I think many of the traditional problems have been actually effectively solved. As Bayan mentioned, some of the initial getting data and putting it into one place has been solved effectively. One of the key problems that we are plan to focus on for this year, ties back to what you mentioned, Peter, earlier about the rise of things like Hanssens and other things. The goal is, we've got everything here. What does this mean? What does the data mean? How do I find what I'm looking for? Or how does this all fit together? We've got a lot of stuff there. We've solved a lot of problems, but the last mile problem, as James mentioned, one of the last mile problems for us is, how can we actually say, have an analyst join us at 9 o'clock on day one, get their laptop, their swag, their water bottle ready at 9, query the data lake at 10 o'clock, do some analysis, understand the data, and then be able to answer a question, do some fancy machine learning stuff by around 3 o'clock, and then provide a presentation to somebody by 5 o'clock. That's our key goal for next financial year, because I think a lot of the hard stuff has become boring now. Now, this is going to be what we are excited about. How can we make an analyst productive in 8 hours?
That sounds super tough. You know, sometimes when you look at the onboarding process into data teams, you know, people talk about 3 to 12 months or something like that. So I would be fascinated to, and I'm sure, you know, you've definitely got the smarts within your company to achieve it. So I'm fascinated to hear if you do actually achieve that in 2021. That'd be a massive milestone. So, you know, good luck. Suneeta?
Yeah, so talking from my experience, I think in the area that I'm in, there's a lot of data problem that needs to be solved actually. And talking about the high level, like data discovery, it's much easier. Like, it's a hard problem. It's not solved. Not every organization has solved it, but it becomes much more harder when you're talking about multimedia content, images. You know, like, you have got petabytes of images. I want to find that image where there is a roof or a trampoline in a backyard. How do I find that? Yeah, you can't do that with the metadata, and there is no way to discover that. Then once you have a system in place, then when you start to train the model, you kind of want to pick up the best sample that would give you the best model training. So then again, it comes back to the discoverability, identifying what I need to pick. So and it's really, really hard to do if you don't have the right system in place. Like we can't really go into the visual content. We kind of need to build the analytics derived from that image. And it's a solvable problem. But the point is that we don't really have a cookie cutter software system in place that we could plug in and that allows you to do this seamlessly. You kind of need to build in or put in a data warehouse, then you need to really curate your data, then set up an ingestion pipeline, then obviously you need a way to query that and generate, like, bring it back for the model training. But then do you do it for online, offline? Like if you want to do it for once you're training model, you're kind of bringing it to the GPU. So it really needs to be snappy. Like you can't have the latency on data coming, like even seconds of ETA is quite a lot. You lose the efficiency on the model training side of things. So where I am sitting, the data problem is a really hard. It's not solved. It's much harder when you are in the space of feature engineering sort of thing. And one of the other problem that I see is the data quality. It's much easier to do a data quality control when you are having structured data set, or when you are doing feature engineering. You can put a notion to what you expect in the data. But when you start dealing with images, what is an anomaly? How would you do an anomaly detection? What is a good data set? What is a bad data set? And the problem here is the labelers they generate your data set, what is the ground truth. But as a human, we are not perfect, right? We make mistakes. And then you are already having a problem of kind of not 100% accurate data in there. And how do you do the quality control when you don't really know what should be the right data set? What is an anomaly? So it's a really hard problem. And I think I would be very happy if we start to look at cookie cutter solutions onto what we can do to simplify that. And there are things happening in this industry, I think particularly around things like supervisedly or scale AI, or even I think Appen, who used to be Sydney labeling industry, who were acquired by Figure8, they have been starting to use AI to kind of simplify that. But it's still, I think it's just a start of what it should be to simplify the model development, model building sort of thing, and just solving the whole problem of multimedia content or multimedia data when you want to be training model.
Yeah, fascinating. So I heard sort of data discovery in there, and probably the need for a bit more innovation in the feature engineering labeling space of the sort of deep learning workload. So yeah, that I think do you see a place for data engineering helping out in that regard, like with the data discovery and also with other aspects of some of these unsolved problems with data labeling and things like that?
Yeah, definitely. In my opinion, I think this is purely a data engineering problem, and there's a clear need. I think it's more about how we can make that happen, or realizing that gap and kind of coming in to bridge that gap. In my view, and correct me if I'm wrong, but a lot of the focus has been working with the what I would call textual data. Like there isn't much focus on what you can do with the multimedia content. And that's where the gap is. Like if I take the same problem and transform into, say, like financial data, and then there is much more support for systems and software and data engineering tools that you could put in place to solve that problem and give people or organizations more bandwidth to do things that they want to do, like really consume data. But that's not much solved in the multimedia context. But having said that, it's the same problem. It's just that the nature of data is kind of different.
And it's bigger, like file sizes and things like that. Yeah, it takes a lot more to churn through it all. James and Kelly, I wanted to quickly ask you, we've had a few questions from the chat. What are the main technical and non-tech skills that you see most relevant for data engineers? Like if you're, and it's, I think Kai, if I've pronounced the name correctly, has asked a similar one. If you're trying to get into the data engineering space, what sort of skills would you recommend learning first and foremost?
I'll go, or do you want to go, Kelly?
Go ahead.
I would start with SQL, and I think there's an obvious resource, I guess, on this webinar where you could maybe start. But yeah, I think there was a period where people thought that was going to go away. Clearly, it didn't. And SQL is a lot more than just select and where. There's a huge amount of analytical functionality available in data warehouses now that there's a huge amount you can do just in terms of discovering the data and pulling it apart from within the warehouse. I think once there's a level of comfort with being able to just change the shape of data and understand all of the basics about data types and which ones you should be using in what situation. The next step, I guess, is how do you do that in a real environment like a workplace, and that's where I think it's good to start getting familiar with how to manage those scripts. Obviously, DBT is a really popular one at the moment, but definitely, I guess that's something you can typically learn on the job. But there's nothing stopping someone from getting a cloud data warehouse account trial or otherwise, and just getting started with some basic tutorials with DBT. And that really gets you the full process of, bringing some data into the environment, transforming it, making it ready for someone to consume. Kelly, did you have anything to add?
I'm glad you said the SQL bit. Yeah, I think from a soft skills perspective, I mean, this isn't anything new, but maybe it hasn't been solved, or maybe it never will be. But I feel like, being able to translate what's a business problem into data is like still, it's a hard thing to master, and it's an ongoing learning process. And I think, I mean, you kind of need your organization to buy into putting the resources towards that. But being able to communicate a message and again, translate it across that fence is so valuable. And only, I think, a very small group of people today do that successfully and consistently. Yeah.
Yeah, I completely agree. I was just thinking about the best data engineers I've worked with, and they've had that skill set. They understand how the business works, and so they can understand how to manipulate the business's data. So, yeah.
Yeah, definitely. I think, would you say sort of pushing more towards the more technical data engineer, I guess? So a good starting spot is having those SQL skills, getting a bit of data warehousing skills, perhaps, learning Kimball methodology if you wanted to get into that space, or a bit of using perhaps an open source visualization tool could get you a bit of that rounding in analytics and, I guess, understanding and practicing how to present data back to a business. When you want to get into a bit more sort of advanced data engineering, perhaps learning, Python or Scala, learning some sort of data transforms, getting some understanding around data lakes like S3 buckets and things like that. Any thoughts on that? Perhaps, yeah, it was too much of a leading question. Kunal Tirawi has asked, do you see a gradual transition from pure data engineering towards more of an analytics engineer with advancement in cloud tooling and technologies? Obviously, we're talking about, likes of, Fivetran, Omnata, all of these sorts of tools. What are your thoughts on that?
Yeah, I'm obviously excited about the modern data stack and what that means. I really enjoy watching things that used to be really expensive and complex become simple. And things that big tech companies did, with teams of 100+ people, gradually turn into something you can do in a very small company. That's to me almost as exciting as the creation of the technology itself, because I think one thing in Australia is we don't have a lot of large tech companies that are headquartered here, but we do have a lot of very innovative small and medium-sized companies that are doing really cool things with data, within various industries. And the fact that, they can do a whole lot more now with a whole lot less is really exciting. Public cloud companies did a great job of bringing all those platform as a service tools to just make engineers more productive. But now there's all these software as a service companies, Fivetran, as you mentioned, DBT Cloud, who are basically meaning that so much of it is abstracted away now and provided at such a relatively low cost that you can have a really small team doing really advanced things. And so yeah, I think it's really useful to know a lot about infrastructure, and it's useful to have a really solid technical foundation, but I'm also excited that it's no longer a prerequisite either. And it's perfectly valid to be an analytics engineer who achieves quite a lot without having that broader technical skill set.
So Nicholas Tan has asked about, in terms of data modeling, with the advent of these next-gen data warehouses and the like, is data modeling becoming defunct? Perhaps, Nitish, you could offer some thoughts, potentially.
Look, ultimately, if you think from the point of view of the user, right? You are an analyst. Your goal is to do things the easiest way possible. I'll give you an example. We, when Redshift Spectrum came out with the support for JSON data types, and then people had to write slightly complex SQL to do select schema.column dot, and then a couple more dots, we lost them. They said, this is really good. I love this, but can you flatten the hell out of this and make like a 100-column table? So, and secondly, people don't like to join if things are nicely, beautifully presented in one place. Because ultimately, if you think about it, right, the magic in data is when you bring in transaction data with Zendesk data, with Salesforce data, everything in one place, and then suddenly you see patterns across each other. And if you can model data very well from the point of view of the user, then that's definitely a valuable skill to have. Because for that, I think I really like what Kelly just mentioned, right? The translator bit, understanding the end user's pain point, and then making it easy for them to consume data that Fivetran and others have bought, using DBT or whatever, as James and Bayan mentioned, right? Yes, definitely you need to really empathize with the end user, understand the strengths and weaknesses of the technologies, bring it together in a very easy and performant way is very tough. And I believe data modeling, right? Just thinking about a table, you need to really understand in depth what are the pros and cons of whatever technology you're on, Databricks, Snowflake, Redshift, whatever it is. Snowflake is amazing. You can still write an extremely poor query in Snowflake. It's and you can actually design a Snowflake schema and everything in a very poor way. It's still and it's surprisingly extremely easy. So yes, I think data model, I would say, is a manifestation of how well you understand your end user's requirement, how well you understand the strengths and weaknesses of your technology, and how do you bring it all together in an easy to even things like table names, right? The wrong table name can lead to so much of confusion, inconsistent column names, right? We've all been there. So absolutely, I think if you think about data modeling, all of us agree that SQL has gone from strength to strength. SQL is useless unless you have got good data models.
Yep, so it's definitely not just a case of just landing it all and just throwing some SQL on top of it. Definitely data modeling is still, and Kimball versus Data Vault, any thoughts on that?
Whatever can get you raw data to consumable data in days, you use it. Whatever works, it doesn't really matter. Because for us, from the end user point of view, they don't care. Ultimately, I'll give you an example, right? Yesterday, somebody in our company asked me, look, we really need to get SendGrid data into the system. The expectation is that SendGrid data will be available in a consumable model format by Tuesday next week. And thankfully, Fivetran has got a connector for that. And then the expectation is it should be ready by Tuesday. So data vault, Kimball, whatever works, you do it. It's not weeks, it's days.
Yeah, and that's generally when people build out data models, it takes months and months and months, doesn't it? So that's incredible velocity.
And
Any other
things like DBT and things, right? If that is in your ecosystem, that can help you. I mean, you've got transformations for any of these standard data sources. Somebody would have already done the work. It's the open source community is extremely vibrant in these areas. You should not have to reinvent the wheel. We're not building everything internally. We're trying to actually copy shamelessly.
Yeah, and I think that's the thing, leveraging these patterns and frameworks, isn't it? It's really what's reinvigorating the whole data and analytics space for sure. Anyone else would like to comment on the data modeling space?
I would just like to add that to the original question, is that going to be obsolete? I kind of agree with Nitish that it's a core part of, like, if you have got data, if you're managing data, then rendering and surfacing it in the right frame is what makes it usable. If it's not there, then it's really hard to build all these systems that would sit on top of it, like finding it and then building reports or kind of monitoring side of things. It becomes really hard.
Yeah. Yeah, very good point. Conrad has asked a bit of a different question in regards to, I guess, building out a data infrastructure within a modern company born in the cloud. seems to be these days easy peasy. Whereas, if you're still working with a legacy, company that's got lots of legacy data warehouses on-prem, et cetera, that can be quite a challenge. I think that's probably where data mesh is, this concept has been born out of. Any thoughts from the panel in regards to some of these companies? Kelly, have you worked with a few companies in your time at Snowflake that have required to sort of, I guess, modernize into the cloud, if you will?
Yeah, James could probably talk to them.
Yeah, I can really testify to this. I've worked in companies that existed before computers, and I've worked in completely new companies that are starting from scratch. And absolutely, it's much easier to start new by a long way. Yeah, so definitely very true. I don't know if anyone would argue with that. But I don't know if we're looking to give Conrad some comfort, maybe the silver lining is that existing companies have momentum and hopefully revenue, and can, if you're someone within a company like that who is good at identifying opportunity, quantifying the value of it, and being able to really build a business case, then things can happen. There's still a lot of work to do, but hopefully the investment is there to back it, even if it's a multi-year journey.
Mm.
Yeah, and I think that value, that having that value, the end goal in mind. Sometimes people start with the how much is it going to cost and what do we have to do today and how long will it take, without thinking about why are we doing this and how are we, like, where are we going? And it seems ridiculous, but it happens more often than you'd expect, especially at large organizations. And it is hard, as James said. I know I saw him go from having to go through a lot of hoops to just having free reign, and he was skipping in the fields. So yeah, it's definitely a different beast.
The other difficult part about it as well is going from legacy to new, is that there's inevitably a period where you're doubling up on cost. So you have this huge mountain to get over, where you have to convince people, you can't cut over on one day, of course. So you're incurring the old platform costs and maintenance, and also investing in the new one. That's really hard. But if you can build a new platform right, and it sounds like Nitish has got a recipe for doing this, where you can tell stakeholders, you can have on the new platform, you'll get what you want in days, not months. Then hopefully that makes that spend look worthwhile.
I wish I could actually dictate that. It's not whether I can get it with, I have to. It's not.
Yes, speed to decision is driving a lot of innovation, isn't it? Just that need for, especially in startup land, how quickly you can make decisions is one of your key differentiators. I think going back to the modeling topic, Dom Colyer from Fivetran asked whether we should physicalize data models still. That means, having those daily runs where you sort of taking those snapshots of data and things like that, or whether we should just build views, given like a lot of the data warehousing platforms at the moment, they're separating compute and storage, so you can throw an incredible amount of compute at a lot of these and return results quite quickly, even, quite tricky views and things like that. So thoughts on that?
I think one of the most interesting things about like Snowflake and BigQuery is that they've taken the performance problem of other tools, like For example, previously Redshift, I know they've added new features, but for example, Redshifts lack of separation of compute and storage and made it into almost a cost problem. So it depends on how much you want to pay and how much money you have and how big your data is, I guess, right?
Yeah, I guess one could argue that along the same lines that, pre-computing means that you do it just the once, especially if it's being accessed, multiple times a day or something like that.
And I don't know whether you're familiar with, there are so many companies like AtScale and other abstraction tiers on top of this, because people's expectation of queries running back is exactly the same, right? We are in the Facebook generation. A BI page is a web page, right? You're running a BI report. It may be scanning 1 billion rows of data. The expectation is it comes back within 2 seconds. It's not physically possible to bend the laws of physics. So they have in-memory there. So I think we'll always have these expectations of extremely high performance, no matter what the volume. So at that point in time, we just need to get creative, right? But for some users, they are more power users, they understand that it is churning through a lot of data and they're okay to wait. And how we've actually solved some of those things is very easy. We just gave them a scheduler and then they schedule things and then they're extremely happy because they don't have to wait even 1 second because they schedule stuff which they run on a daily basis, and people go nuts. We've got thousands of queries are hitting our Redshift cluster every day. It's like I keep telling people, we've given a machine gun with unlimited bullets, and people enjoy, and they're very productive because we've got almost 100 users who actively use SQL in an 800 people company, right? And out of that, imagine that about 300 to 400 people are in completely non-technical roles. So it's like 30% of the people who are even related technical roles are writing SQL. And it's transformed the way data is used in the company. But there's one thing that has not changed in the 15 to 20 years I've been in data is patience. People want things to come back in 5 seconds. 20 seconds, 30 seconds is too slow. So if you can meet the expectations of the people with less engineering, that's beautiful. I think it's the right way to do it. Especially tools, technologies like Snowflake, who've got built in for performance. I think if you can not do all this additional eng work, I think it's a magnificent thing.
Very good point. Well, we're pretty much at time, so we might just go around the panel with final thoughts in terms of your thoughts on the year and what to expect next year. So whoever wants to jump in first, go for it. What are you excited about for 2021?
I'll start. I'm like a broken record, but I'm excited about companies like Super Cool Data and Omnata. And I really do mean that. I mean, like just seeing that journey. The other thing that was really cool about, watching those startups form is they were born out of experience and out of, real life. And so, that there is a problem that they're solving. And then, just having it come out of our local community has just been really cool. Been super cool.
Thanks, Kelly. I guess for me, it's the ease with which you could set up. So the most impressive thing for me was when I kind of had to set up my own company. A lot of my students who signed up to the pre-order, they're all on BigQuery. They all use Google Analytics. I had to set up BigQuery, Fivetran, and it just it took me about 15 minutes to kind of get Stripe, MailChimp, my search, Google Search Console with Fivetran. It was just unbelievably fast. How quick it was to set up the whole thing. I couldn't believe it. So I think that's really exciting to get all of those components. And there are still things like turning your data warehouse, making it operational, making it useful in decision making. That's still not easy to do. Using real-time data, it's still not easy to do. So all of these things are going to be a lot easier to do for anyone who's perhaps less technical. So some of my students are actually, they're as least technical as you can get. They're marketing people, and they can set up their own data warehouse. They've flicked the switch in Google Analytics, the new Google Analytics. Now all their data is streaming to BigQuery, and now they're writing queries, and now they've got Data Studio already set up. So to me, that's really exciting, just how quickly, how easily it is and how quickly it is to set up the whole stack. That's just fascinating. I was just blown away by that.
Suneeta?
Sure. So I think a couple of things on my side. We're kind of redoing the data systems to hold all these model related data that I spoke about. And although there is a component of custom code more than we would like to see, but there is still many systems that's out there. Things like Snowflakes are a part of this. So I'm excited to see, looking into 2021, to what these tools can do to help some of the problems around, things like identifying the right data set that you want, effective sampling for model training sort of thing, that kind of leads from these data discovery pieces. And also building on to, there's some new approaches that's coming in on how to efficiently do these data generation, like, the labeling. So that this incrementally being adopted by new organizations who do labeling. So I think things like that would be exciting looking forward to 2021. So in a sense, in many ways, looking forward to utilizing these new concepts around how to build the right data warehouse, data systems.
Okay, cool.
Yeah, I think obviously I'm excited, with what my own company is doing with helping people have wins in production or affect real change within their company as an extension of their analytics work. But separately to that, I think it's good to see gradually that in the machine learning space that I've had a frustration for a long time that data scientists are expected to think a lot about infrastructure. I've never really thought that was fair, and it's taken a very long time for that to start to change. Data scientists being trained up now, being feeling pressure to know, how large an EC2 instance they need and how many of them and what's appropriate for sizing. I'm not selling anything in that space, but I'm excited to see it gradually start to get solved. I think Google are paying a little bit of attention to this now, which is good. And I think if you combine the improvements in data engineering with the improvements in data science, and by improvement I mean making it easy as it can be and to let people focus on the problem they're actually trying to solve, that you don't need all these specialized skill sets, and you can just, like Bayan said, 15 minutes, get the pipeline up and running. Hopefully in a matter of hours, you've done some feature engineering and training, and you've got some analytical output, and then something that lets you plug it into whatever your system is. If 2021 makes it easier to do all that than it was this year, then I think that's a good thing for everyone.
Look, there are three things that I'm very excited about. One is I think the tremendous competition between vendors in the industry is very, very useful for people like me. I mean, I'm sure Databricks makes Snowflake better, Snowflake makes Redshift better. So, so I think that is the pace of innovation that I've seen in the last 3 years surmounts anything that I've seen in the previous 15 years I've been doing things data. It's tremendous. What that leads us to is people like me have no more excuses to give to users that you have to wait 2 weeks for value. So I'm in trouble because I can't give excuses anymore. I think the second thing is, I think there is tremendous amount of work being done in the education sector in Australia and other places on making the new generation more aware of data, right? Being more literate on I think that's phenomenal. And I think if you think about this year, right, the awareness that has come into things like data sharing for solving the pandemic issue and collaboration across industries, just to touch upon innovation like the data sharing stuff that Snowflake is trying to do, right? I think there's a more community feeling on, can we solve problems other than simple business problems with data? There are other things that are facing the world. Can we help as a very technically advanced area, and which is innovating? And is there a bigger purpose to all of this stuff? Hopefully, we are able to answer some of these questions in 2021.
Awesome. Well, thanks everyone for your time today. Really appreciate it. I think it's been awesome to have such a wonderful panel with such diverse sets of experiences within the industry. Thanks once again to Suneeta, Nitish, Kelly, James, Bayan. It's been great. Thanks for taking the time out of your day to share a bit of your experience with us. And yeah, have a happy end of year festive season, and see you all in the new year. Bye.
Thanks, Peter.
Thank you. Thanks for having us.
Bye.
Everything's, yeah.